Okay, so today we are going to discuss the current ISS paper. It is the ISS paper 1 and 2 for this year 2022. Okay, so let me share the paper with you. These are the two papers. This is paper 1, as you can see, and this is my paper 2. Let me increase the size. Okay, so we are going to discuss a few sums chosen randomly. Okay, so let us start with this particular sum. Let me start with question number 5. Okay. Okay. So question number 5 says that if x follows a Poisson random variable with this criteria that probability x equals to 1 and x equals to 2 are same, then what will be the value of variance of x? So one thing we know that if x is a random variable following Poisson with lambda, then it implies that expectation of x is equals to variance of x is equals to lambda. So we are assuming this that x is a random variable following Poisson with parameter lambda. Let us assume this. This is my assumption. Okay. So if this is my assumption, then basically what we are doing right now is probability x equals to 1 is equals to probability x equals to 2. Okay. So we are going to solve e to the power minus lambda to the power 1 by 1 factorial is equals to e to the power minus lambda square by 2 factorial. Okay, that implies lambda is equals to lambda square by 2 factorial. Since lambda is a parameter and which is not equals to 0, and we assume that lambda is greater than 0, hence basically 2 factorial is equals to lambda, and that implies lambda is equals to 2. Is it clear? And for this reason, if and for this reason we can say x follows Poisson with 2, and that will give me expectation of x is equals to 2, hence variance of x is also equals to lambda, that is equals to 2, and this is going to be my answer. So let's check the options. Option C is my answer. So my answer is option C, 2. Next, let's search for some other sum. Okay, let's try out this one. X follows a binomial distribution with n equals to 3 and p equals to 1 by 3. Then what will be the value of expectation of x minus 1 whole cube? As much as I can say, it's a whole cube. So let's try this out. Question number 6. X follows binomial distribution with n equals to 3 and this. So basically this is the value of n, this is the value of p, and they asked me to find x minus 1 whole cube, right? So basically, what I can actually do, I can break this up and I can find the whole thing, but that won't help me because we know for any kind of discrete distribution like Poisson binomial, not all basically, but maximum kind of discrete distribution is very difficult to find this x cube, x square, and all those things. And hence, for finding the variance of binomial, we instead of finding expectation of x square directly, we actually opt for finding x square like this, x into x minus 1 plus x. We go for this method. So we will go for this method as well over here. So we will actually not going to find x minus 1 whole cube directly. We will try to find something which is going to help me to find this thing out. Okay, so basically we are going to break this up first. We are going to break up this x minus 1 whole cube. What will be the formula? That is x cube minus 3a square b, that is 3x square into 1, plus 3ab square, that is 3x into 1 square, minus 1 cube, that is 1. So that is the thing basically. So now we have expectation of x cube minus 3 expectation of x square plus 3 expectation of x minus 1. This is the thing. And we have to find expectation of x square, expectation of x cube, expectation of x. So since we are pretty much habituated in finding variance of x and already expectation of x is known to us, so in expectation of x we can write np. So it will be plus 3 into np minus 1 minus 3 into, if you can't remember expectation of x square, at least we know for binomial variance of x is npq. And the formula of variance of x is basically expectation of x square minus e square x, that is equals to npq. That implies expectation of x square is equals to npq plus e square x. So that gives me npq plus n square p square. So I'm going to write that thing over here, npq plus n square p square. And we are left with this thing because we don't know how to find particularly this thing. So one thing you can do, you can find this expectation of x cube directly without there are two methods of obtaining this thing. One thing is you can find out expectation of x cube in this way, like x into x minus 1 into x minus 2. You can find out expectation of this thing and you can adjust the remaining term. So that will, you can adjust, you can do a plus minus of the remaining term, but this method is very lengthy. This method is large. So to avoid this thing, what you can do, you can remember the formula of MGF. MGF is Q plus P into e to the power t whole to the power n. This is the formula of MGF for binomial distribution, and you can directly do the third order derivative of this particular thing and can put t equals to 0. So before I put t equals to 0, I would like to do the third order derivative of this particular thing. So let us start with the first order derivative. That is going to give me n into q plus p into e to the power t whole to the power n minus 1, and it is going to give me q plus it is going to give me 0 plus p into e to the power, it is going to give me 0 plus p into e to the power t. So I am not putting 0 because I don't need this, but if I put 0 it will give me np. I know that. Next I am doing second order derivative of this mxt, which is the ddt of np e to the power t q plus p e to the power t whole to the power n minus 1. So this np will come out and we will do the derivative with respect to t. It's xy function. So e to the power t is doing the derivative of e to the power t and remaining this part as same. And in the next step, keeping the e to the power t and doing the derivative of this thing. And it will again give me 0 plus p into e to the power t. So we are not going to put 0 over here as well. Next, we are going to do the derivative of, which is nothing but d dt of np into e to the power t into q plus p into e to the power t whole to the power n minus 2 will get common, and then basically we are going to have this n minus 2 will get common, not n minus 2, sorry, don't take n minus 2 common, let it be n minus 1, and plus np e to the power t n minus 1 p e to the power t q plus p e to the power t whole to the power n minus 2. This is going to be the whole thing. Now let's see what we can take common, which is independent of t. That is np into n minus 1, not np. From over here, we can take common n we can take common, p we can take common from both the terms, and n minus 1 we can't take common. So sorry for I can't write this. So np we can take common from both the terms, so what remains inside is d dt of basically e to the power t q plus p into e to the power t whole to the power n minus 1 plus 1 np remains common, so 1p still left inside, so n minus 1 into p e to the power t whole square q plus p into e to the power t whole to the power n minus 2. Now going to do the derivative directly. So for the derivative, again this p plus q rule for the first section, p into q rule, that is going to give me e to the power t q plus p into e to the power t whole to the power n minus 1 plus e to the power t into n minus 1 into 0 plus p into e to the power t. That is for the first portion. We have, I'm writing it in a blue bracket. And for the second portion, we have n minus 1 into p e to the power 2t we have basically. So for writing e to the power 2t, we will do the derivative of e to the power 2t. So e to the power 2t is going to give me, or e to the power t whole square, e to the power 2t, that is e to the power mx, that is m into e to the power mx, that is my derivative over here, and my q plus p into e to the power t whole to the power n minus 2 will remain same, plus e to the power 2t will remain same, and I will do the derivative of this n minus 3 into q plus p into e to the power t whole to the power n minus 3 into p into e to the power t, and that ends up my last derivative. And then what I am going to do in this very big term over here, I am going to put t equals to 0. So d cube dt cube dt cube of this mxt at t equals to 0 is going to give me, let's see what is going to give me. I'm going to put t equals to 0 in this line. It's going to give me np as it is, e to the power 0 is 1, and e to the power 0 is again 1, q plus p is 1, so 1 to the power n minus 1 is again 1, plus e to the power 0 is again 1, we have n minus 1, we have p into 1. That is the first portion, plus n minus 1 into p, and again we have 2 into e to the power 0, that is again 1, q plus p will give you 1, plus e to the power 0 is 1, it's giving you n minus 3, it's giving you again 1, and it's giving you p, and it's ended up. So it needs a little more simplification. It needs 1 plus n minus 1 into p plus n minus 1 into p into 2 plus n minus 3 into p. Further simplification is needed. That is np into 1 plus n minus 1 into p plus n minus 1 into p into 2 plus n minus 1 into n minus 3 into p square. That is the value of basically my expectation of x cube. So we are going to put this value over here and going to find out my value. So obviously, since these are based on NP, so what we can do directly, we can put the value of N and P and we can simplify it directly. So N was 3, P was 1 by 3, and it was 1 plus N minus 1 is 2, P by 1 by 3 plus 2 into n minus 1 is 2, p was 1 by 3 plus n minus 1 is 2, n minus 3 is 0, and it is p square is 1 by 3 whole square. So let us put the values and get the values directly. So that is equals to, this is 1, so no need to write, and this is 1 plus 2 by 3 plus 4 by 3 plus 0. So that is going to give you 9 by 3, that is 3. I am writing this one as 3 by 3, so 4, 5, 6, 7, 8, 9. 9 by 3 is going to give you 3. So let's go back at the top where we are obtaining this value. So this value, after putting the value of n and p, is going to give me 3 minus 3 into npq is 3 into 1 by 3 into 2 by 3 plus n square is 3 square into 1 by 3 square plus 3 into 3 into 1 by 3 minus 1. Closes over here. So let's simplify this thing over here. It is going to give me this 3 will cancel out, this 3 square will cancel out, and this 3 will cancel out. We will be left with 3 minus 3 into 2 by 3 plus 1 plus 3 minus 1. So that is giving me 3 minus 3 into 2 by 3 plus 3 plus 2. Again 3 minus 2 plus 3 plus 2, and that is 5 minus 5, that is equals to 0. So the ultimate answer is 0. Is it okay? Is this calculation clear?
Yes, ma'am.
If you want, you can proceed in this way as well, but this is going to give you a little bit large method. But if you wish, you can proceed in this way as well. Okay. Now go for some other sums. Okay, let's do question number 11. Okay, what question number 11 says that we have a set of values of x and y. X is 1, 2, 3, 4, 5. So let me write this 1, 2, 3, 4, and 5. And the set of values of y is basically 4, 1, 0, 1, 4. 4, 1, 0, 1, 4. Okay, so they have asked me to find the correlation coefficient between this. First, you need to see that is there any relation between x and y or not. So, like if x equals to y square, non-linear relationship is there, then correlation coefficient will be 0. Is there any non-linear relationship? So, can we identify that? Till now, I couldn't identify anything. Let me check it once. I couldn't find anything. Now I can't judge anything. So let's do one thing. Let's start finding out the correlation coefficient. What we need. We need expectation of xy minus Ex into Ey, or the analogous formula is 1 by n summation xi yi minus x bar y bar. Okay, so what we can do, so let me rub this thing over here. Let me need the space for finding out the formulas. Okay, so let's write xy over here, that is 4, that is 2, that is 0, that is 4, that is 20. Okay, and we are going to have the totals over here. 10, this is 15, and this is 20 plus 4, 24, 25, 26, and this is going to be 30. Okay, so if I am doing something wrong, please check the calculation and just let me know. Okay, and so we need to find uh, my covariance of xy, that is going to give me 1 by n summation xi yi minus x bar y bar. So here n is basically my 5, x bar is 10 by 5, that is 5, sorry, 15 by 5, that is 3, y bar is 10 by 5, that is 2. Okay, so we are left with finding 1 by n summation xi yi, that is 30 by 5, so that is 6. So we can find the covariance easily. So the covariance of xy is nothing but this thing, this 30 by 5 minus this 15 by 5 into 10 by 5. So 6 minus 3 into 2, that is equals to 0. If the covariance is 0, obviously basically the correlation coefficient will turn up to be 0. So that's why I have first obtained the covariance, because we don't need to put our time and computational labor on finding the variance, because first we need to check the covariance, because if it is coming to be 0, then obviously the covariance will be 0 and A is 0. Okay, this was a very easy sum. So let us move on to something else. Let's see the right side. These are not clearly visible, though. We have done this one. Yes, we can try out this question number 7. No, 7 is not visible clearly. 6 minus y or plus y. I need to check this once again.
Excuse me, ma'am.
Yes,
Ma'am, you have done second problem, no, ma'am.
second
In that
problem.
there is no option 0. No binomial
This
problem. Previous problem.
this one.
Okay, okay. Not able. No, ma'am. Previous problem.
Which one? Which we I was doing?
Yes, ma'am.
Okay, you were saying the option was not matching basically, right?
Yes, ma'am.
Wait, it was maybe some calculation error. Let me check it once, okay?
Okay, ma'am.
Have you checked the calculation while I am doing? Have I made any mistake?
Yes, no, ma'am. I can't find. I didn't find any mistake, ma'am.
Let me check it once. Just give me 2 minutes, okay?
Okay, ma'am.
Just check with me the derivatives. Have I made any mistake or not? Okay.
Okay, ma'am.
The first one was this one. So let's check the derivative. N into this to the power n minus 1 0 plus p into e to the power t. In every step, let's just put the value and check it once. Okay. So here, if I am putting the value of np, it is just giving me np e to the power t q plus p into e to the power t whole to the power n minus 1. Okay. So if I am putting it as t equals to 0, then actually it is going to give me np. So the answer is correct. Derivative is correct. For the second order derivative, it should have given me this thing, this npq plus n square p square. So let's check this, whether it is giving me this thing or not. So into n minus 1 into 1 into p. So that is giving basically np into 1 plus n minus 1 into 3. So that is np plus n some is including on square and p square. So inside p square plus np into 1 minus p. Yes, it's right.
Yes,
npq
ma'am.
basically. So I have made a mistake
I
over
think
here, I guess, while putting t equals to 0. Let's check it. T equals to 0, e to the power t is 1. This is going to give me 1 plus e to the power 0 is 1 and minus 1 is 1, and this is going to be p. So this gives me like np into 1 plus n minus 1 into p. This is the
yes,
first
ma'am.
portion. Okay. np is outside the first bracket. Okay, so this second portion gives me this n minus 1 into p, 2 into e to the power 0 is again 1. This is going to give me 1 plus e to the power 0 is 1, and this n minus 3 into this is 1. This is p into e to the power 0 into 1 basically. So that is going to give me, let's check it, n minus 1 into p, so 2 plus p into n minus 3, and this is 1 plus n minus 1 into p. So put 1 plus. Till now, I find this correct computation is correct. After that, can you put the values and check and tell me once?
Okay, ma'am.
Let me check the sum again. Two.
I don't find any mistake, ma'am.
Yeah, so that might be. Let's wait for the answer key. I think the answers are wrong. Okay, so I
Okay,
will
ma'am.
do it again, and if I find any flaws or mistake, I will let you know in the next class. Okay.
Okay, ma'am.
So let's start and do another sum. The question is so hazy; it's very difficult to see some values. Actually, I am in a doubt whether the power of this x minus 1 is 3 or not.
Three only, ma'am.
Yeah, this one.
Three only, ma'am.
Yeah, this I can't see it properly. Can you see it?
Yes, ma'am.
What's the power? Is it
Three.
3?
Yes, ma'am.
This
Three.
power.
Three, ma'am.
I don't know. I can't see it properly. It's too hazy. Let me check it once. Then I will let you know the final answer. Okay?
Okay, ma'am.
So hazy that I can't see it properly. Where was I? Yeah, let's do this question number 14. Okay, it is given that n equals to 4, summation x square equals to 164, summation x square equals to 572. So let me write up the informations. Question number 14. N equals to summation xi square equals to. So it gives me n equals to 4, x square equals to 164. N equals to 4, x square equals to 164. Summation yi square is equals to summation yi square is equals to 572. 2 and summation x is 24, summation y is 44. Summation x is 24, summation y is 44, summation xy is 300. They are asking that what is the estimated value of x when y equals to 0. So that means I need to find a regression equation of x on y. So that where y will be the independent and x will be the dependent one. So like I need to find something like x equals to a plus bx kind of thing. So sorry, x equals to a plus by kind of thing. So obviously we know for regression equation of y equals to a plus bx, b hat is covariance xy by variance of x, and a hat equals to y bar minus b hat x bar. So obviously let's see whether the changes is what the changes makes and how it is going to be. For x equals to a plus b into y, what will be the value of b hat and what will be the value of a hat? Okay, so let's start doing this. So summation over EI square, that is the error what we are going to have, because we always have an error with this, that is going to be basically in this case the error is going to be summation over I xi minus a minus b into yi whole square. I'm just doing it roughly to show you for the confirmation. How to remember this, that I am telling you later. Just it will take 5 minutes. So I am doing this. So summation over I. This is this is basically, let this called be some SS square. Okay, SE square. I'm just renaming it. Okay, so now we are going to do the partial derivative of this SE square with respect to A. That is going to give me summation over I twice xi minus a minus byi, and with respect to a I'm going to get a minus 1. So that is minus 2 summation over I xi minus a minus byi. Okay, so let's equate this with 0. So now S E square by del A is equals to 0, implies summation over I xi is equals to NA plus B summation over yi. That is my equation 1. Okay. Now let's move on to equation 2. Del SE square by del B, that is equals to, that actually gives you basically summation over I xi minus a minus b into yi into minus b minus into minus of yi. So that is giving me, sorry, minus 2 yi. So minus 2 will come out of the summation over I yi into xi minus a minus b yi. So now let equate it with 0 as well. Del SC square del B equals to 0, implies summation over I yi xi is equals to summation over A summation over I yi plus summation over I yi square into B. That is my equation 2. So let's solve equation 1 and 2. So solving 1 and 2. How to solve 1 and 2? There it was equation A. So how to solve 1 and 2? The trick we are using, multiplying equation 1 with summation yi. Multiplying equation 1 with summation yi. So what was my equation 1? Equation 1 was this thing, summation xi. So let me multiply this. So summation xi summation yi, that is equals to a into summation yi, that was na. So let me na into summation yi plus b into summation yi square plus b into summation yi whole square. That was my new equation, which I can name it as 3. And now I am going to subtract my equation 2 from it. Okay, so my equation 2 is summation yixi is equals to a summation yi, and then it is basically, okay, not only this, this is going to give me equation 3, and I am going to get this equation by multiplying this equation with n plus n into b into summation yi square. Before subtracting, I will write this. So let me write, and how I am getting this, this is equation 4. I am getting this by multiplying equation 2 with n. Okay, so now I am doing 4 minus 3. 4 minus 3 is going to imply n summation xi yi minus summation xi summation yi. That is equals to, this term will get cancelled out. We will be left with nb summation yi square minus b summation yi whole square, this thing. Now that we are going to divide both side with my n square, 1 by n square. So that is going to give me summation xi yi by n minus x bar y bar is equals to b into variance of y, and that side is going to give me covariance xy is equals to b into variance of y. That implies b hat is covariance xy by variance of y. So what the change we have over here, if you can see, just to the reverse thing, I should have written it directly, but just to show you I have not written it. So it's just the reverse thing what we have. Since covariance is a symmetric function, it will remain same. Instead of variance of x, you will have variance of y. And here you will have x bar minus b hat y bar. It will also change. So these are the things and what you have to obtain to get this equation. So you have to obtain x bar. So from the given data, my x bar will be summation xi by n. My n is given to be 4 and summation xi is 24. So 24 by 4, that is 6. Okay. I need my y bar, summation yi by n. Summation yi is my 44. So 44 by 4, that is equals to 11. So x bar y bar is sorted. Only I need variance of y now. Variance of y is 1 by n summation yi square minus y bar square. So summation yi square is given 1 by 4. What is my summation yi square? Let me see, 572. Sorry. This is 572. This is into 572 minus y bar is 11 square. So let's compute this. 572 divided by 4 is going to give me 143, and minus 11 square is 121. So 143 minus 121 is basically gives me 22. So variance of y is 22. Now comes the covariance part. So for finding the covariance, let's increase this line a little bit. The covariance of xy is 1 by n summation xi yi minus x bar y bar. So let's write this. Summation xi yi value is given. Summation xi yi is 300. So it's basically 300 by 4 minus y bar is 11 and x bar was 6. So 300 by 4 is going to give me 75 minus 66, and that is 75 minus 66 is going to give me 9. So ultimately what I can write, covariance xy by variance of y is equals to 9 by 22. This is the value of b hat, and my a hat is equals to x bar minus b hat into y bar. So x bar was 6 minus b hat was 9 by 22 into y bar was 11. So that is 6 minus 9 by 2. 9 by 2 means 6 minus 4.5, and that gives me 1.5, that is 3 by 2. So these are the two values. So what is the condition of the line? So we get the line as basically x equals to 3 by 2 plus, what was the value of b hat? Let me check it again. It was 9 by 22. Sorry, 9 by 22 into y. This is the value of particular thing. Now we have to find x when y equals to 10. So 3 by 2 plus 9 by 22 into y is equals to 10. Now you need to compute this. So let it be 33 by 22 plus 9 by 22, 90 by 22. So let's compute this. This is 90 plus 33 divided by 22. So it will be 5.59 approximately equals to 6. Let's check this. 5.59. This is your answer. Is it clear?
Yes, ma'am.
Okay. Also, in this method, what basically you have to do in the exam, you don't need to compute this part, this computation part of doing this equation part, no need to compute. Okay, I just showed you just to show you the justification that why it is coming to be reversed. Okay, because covariance are symmetric functions, it will be same, and these are not symmetric. That's why these are changing. So only this changes. So if you can remember the usual thing, that is y on x. If y on x is this, so corresponding b hat and a hat will be this. Then only you can make the changes. Other values are given, you will be finding these values on the left side with red. You will directly find the value of b hat, a hat, and this equation. Finding this calculation, doing this partial derivative, all of these things you don't need to actually do. Okay, so these are like for your justification purpose, so that just you can recall the calculation and you can see what is we are doing is actually true or not. Is it okay? Is it clear?
Yes, ma'am.
Okay, so any queries?